Adanga. Hello everyone, this is Night Daisy, a student at Macquarie University, currently in my second academic year. I'm going to take you through the next part of respiratory disorder, which is expiratory data analysis and data cleaning. And these are some of the contents of the presentation. Heat maps, correlation matrices, box plots, feature independence plots, outliers, patterns of interest, time and space trends, data cleaning, data splitting, training and testing, model training, tune hyperparameters, and lastly, evaluation and validation states. In the introduction, I'll show you some of the libraries to be imported to us to allow the loading of the SV file from the data set. And after importing those libraries, this is the output. As you can see that the file has loaded. Heat maps. I'll explain to you what heat maps are, which are graphical representations of the data that utilize color-coded systems. Their primary purpose is to better visualize the volume of location-stroke events within a data set and assist in directing viewers towards areas on data visualization that matter the most. This is the code I used, and this is my heat map that I generated from my data set. As you can see, there are so many colors that you can use. This is my preferred color. Secondly, I'll take you through the correlation matrices. A correlation matrix is simply a table which displays the correlation coefficients for the different variables, and this depicts the correlation between all possible pairs of values in the table. It is a powerful tool to summarize a large data set and to identify and visualize patterns in the given data. This is the code for the correlation matrix, and this is my correlation matrix from my data set. Also have box plots, and a box plot is a standardized way of displaying the distribution of data based on a 5-number summary, that is to say, minimum, first quartile, range, median, third quartile range, and lastly, the maximum. It tells you about the outliers and what their values are. They are used in statistics to graphically display various parameters at a glance. This is my box plot I generated from my dataset. We also have feature independence plots, and these are variables that you include in the model, explain or predict changes in the dependent variable. When I talk about independence, it indicates that these variables stand alone and other variables in the model do not affect them. These are indicated using a histogram, and this is my histogram. Outliers plots. An outlier is a data point in a data set that is distant from all the other observations. That is to say, these are values below or above the range. It's a point that lies outside the overall distribution of the data set, and it is caused by variability in the data and experimental measurement error. These errors could be human errors or algorithms errors. We also have time trends and time and space trends. These time series. Sorry, in this trends we have what we call time series, which refer to any sequential data point that measure some variables over an ordered period of time. A trend is a pattern in data that shows the movement of a series to relatively higher or lower values over a longer period of time, a long period of time. This is mainly observed when there is an increasing or decreasing slope in the time series. As you can see, this happens when you have two values, that is the x-axis and y-axis. So this shows the outcome. Nextly, I'll take you through the data cleaning process. Data cleaning is the process of fixing or removing incorrect, corrupted, duplicate, or incomplete data within a data set. When combining multiple data sources, there are many opportunities for data to be duplicated or mislabeled. If the data is incorrect, outcomes and algorithms are unreliable, even though they look to be correct. There is no absolute way to prescribe the exact steps in the data cleaning process because the processes will vary from dataset to dataset. But it is crucial to establish a template for your data cleaning process. So as to know that you are doing it the right way every time. In simple ways, data cleaning refers to removing null values, that is to say the zeros from your data set. And this is the code for the data cleaning, and as you can see, we loaded the file from the data set, and here we're checking if we have any null values in the data set. According to my data set, we have no null values in the data set. And the next part is data splitting. Data split. So here we split the data into train, test, and validating states. And I'll take you through the two phases, and that is training and testing phase. In the training phase, the training data set is provided as input in the phase. It has attributes and class labels for training machine learning algorithms to prepare a model to observe relevant data. From that, they find relationships, detect patterns, understand complex problems, and make decisions. The training error occurs by applying the same data from which the model is trained. In the testing phase, the testing data set is as well provided as input to the phase, for which the class label is unknown and is tested using the model. A test data set is used for assessment of the finally chosen model to be used. The testing error occurs when the actual output of the testing data and the predicted output of the model do not match. And that is the code for the phases, testing, training, and lastly, it is the code for the validating set. It's there. Lastly, since my model is dealing with predictions, we have what we call a confusion matrix. which is a table that is used to define the performance of a classification algorithm. It has four parts, that is to say that true positive, false negative, false positive, and lastly the true negative. The true positive shows that in actual sense the patients have the disease and the algorithm was able to identify that. For the false negative, patients with the disease were wrongly the algorithm wrongly identified that the patients do not have the disease, yet in actual sense they have the disease. This is very dangerous as the patients cannot receive the treatment in time. We also have the true negative, where patients without this disease were correctly identified by the algorithm. And lastly, we have what we call the false positive, where patients without the disease that were identified were said to be having the disease by the algorithm. I've almost come to an end of my presentation. Yeah.